From my study of black holes and scaling laws of black hole structures in the universe, I found that the proton, or the nucleus of an atom, could act as a mini black hole. And remarkably, when I calculated the relationship of two protons together, if they were mini black holes, it turned out that their gravitational attraction to each other was exactly what we call the strong force. What is the strong force? Well, the strong force is something we made up, literally, because when we found that the protons were charged, we calculated how strong the repelling charge of two positively charged protons would have. When you take two magnets and you approach the same poles together, the magnets want to repel. Protons are the same. They have a positive charge, and yet they're squished together very, very close to each other in the middle of an atom. So how is that possible? When that was discovered, it was thought that we had to invent a new force, a very strong force that could squish the proton together in the nucleus of an atom against their repelling electrostatic force. However, from what I've discovered, it turns out that if the little protons are considered mini black holes, the gravitational force that they would have on each other is exactly the force necessary to overcome the repelling force of the electrostatic charge. And because these little protons are spinning very rapidly, when we move them away from each other, this very strong attractive force drops off very rapidly, which is what we call the Yukawa potential, or the very rapid drop-off of the strong force. Therefore, I've shown that, in fact, the force that's holding the atom together, or the nuclei of the atom together, is the gravitational force acting on the protons, and because of the spin of the protons being extremely fast, in fact, near the speed of light, the drop-off matches the Yukawa potential that is the measurement of the drop-off of the strong force.